When we think of the Cold War, espionage, nuclear standoffs, and icy diplomacy usually dominate our imagination. But for soldiers, engineers, and civilians living in contested zones, the real enemy was often the cold. Winters in Eastern Europe were merciless, and maintaining warmth in barracks, observation posts, and temporary field structures became a daily challenge. Conventional heating was expensive, fuel was scarce, and inefficient insulation left walls that sapped body heat relentlessly. Yet behind the scenes, a little-known technique, what historians now call the silent Cold War wall trick, transformed ordinary walls into surprisingly effective thermal barriers. Today we'll explore how this method worked, why it was so effective, and how you can adapt its principles for modern cold-weather shelters or historical reenactment. Why conventional walls failed to keep people warm. In mid-20th century military and civilian construction, walls were often simple, thin, or poorly insulated. Standard concrete, brick, or wood-framed structures offered minimal resistance to wind and cold. In winter, interior spaces became heat sinks, with body warmth and fuel heat leaking quickly to the outside. Adding more fuel or blankets was costly and inefficient. The problem wasn't just the material, it was the way walls interacted with air, moisture, and internal heat. Cold drafts created convection currents that carried warmth away, while condensation accumulated in poorly ventilated spaces, reducing thermal comfort and risking mold. Soldiers and engineers needed a solution that worked passively, without complex heating systems, and that's where the Cold War wall trick came in. How the wall trick used layering and micro-insulation. The trick relied on creating hidden layers within walls to trap heat and prevent cold penetration. Engineers discovered that adding lightweight, porous materials between exterior and interior surfaces dramatically improved insulation without increasing wall thickness excessively. In practice, this often involved filling hollow wall cavities with compressed natural fibres such as wool, straw, or felt. Some walls included removable panels or shallow cavities that could be stuffed with these insulating materials on the spot, allowing field units to customize the setup depending on conditions. This principle might sound simple, but its effectiveness was profound. Trapped air, combined with low conductivity materials, dramatically reduced heat loss, creating walls that seemed to hold warmth long after a heat source was removed. Soldiers noticed that rooms equipped with these insulated walls required far less fuel to maintain comfortable temperatures, and the effect was cumulative. Repeated use improved habitability without continuous effort. Why controlling airflow inside the wall was crucial. One of the key secrets of the Cold War wall trick was, managing airflow. Insulation alone isn't enough if air can flow through the cavity freely, carrying heat away. Engineers designed walls so that the insulating layer was effectively sealed against drafts, while still allowing minor vapor diffusion to prevent condensation. This careful balance ensured that warmth from body heat, stoves, or small fires remained trapped, while moisture didn't accumulate to compromise the wall's effectiveness. Modern survivalists can apply the same principle when constructing shelters or cabins. Whether using canvas, plywood, or natural materials, creating a small air buffer between outer and inner layers, sealing gaps, and controlling minor airflow can replicate the heat-retaining properties of these historical walls. Even temporary shelters can benefit by layering insulation materials with a slight gap to allow air buffering without leaks. How soldiers and civilians deployed the technique in real scenarios. The Cold War wall trick was honestly quite versatile. In barracks, interior panels were retrofitted with insulating materials. In observation posts, double-layered walls allowed soldiers to maintain warmth for long hours without excessive fuel consumption. Temporary field structures sometimes used wooden frames with internal cavities filled with wool, straw, or hessian sheets. Even minor adjustments, like orienting walls to block prevailing winds or adding small internal baffles, amplified the effect, creating comfortable spaces in environments that would otherwise have been unbearable. For practical application today, you don't need to replicate historical materials exactly. The principle is layering with trapped air, controlling airflow, and using insulating materials that resist moisture. For example, modern campers can line canvas or tarp shelters with wool blankets or closed-cell foam, leaving a slight gap to trap air. Small adjustable panels or inserts can dramatically improve warmth without extra fuel or power. Why this wall trick is relevant for modern survival and design. The lesson of the Cold War wall trick goes beyond historical curiosity. It demonstrates how thoughtful design and understanding the physics of heat transfer can reduce energy use, improve comfort, and enhance survival in extreme conditions. In both historical and modern contexts, insulation is not just about thickness, it's about layering, air control, and moisture management. The Cold War engineers' solution was elegant in its simplicity, passive, low-tech, and highly effective. By studying these methods, modern survivalists, off-grid builders, and historical enthusiasts can gain practical insights into creating warm, habitable spaces without relying entirely on modern heating systems. The trick reminds us that sometimes the most effective solutions are subtle, silent, and built into the very walls that protect us. If exploring these ingenious Cold War strategies inspires you, subscribe to the channel and share this video. Preserving and applying these lessons ensures that the knowledge of past survival and engineering ingenuity continues to benefit us today.